Right, so we're going to do a mixture problem here. Mixture problems are all the same. There is only one way to do them, and like if you master this one way, then you can basically end up solving all mixture problems without any trouble. So let's get on with this one. Sue's trail mix is 30% nuts, 70% dried fruit. So with all mixture problems, what I just do is I make like two tanks. This is Sue's, and then Jane's, so this is Jane's. Right. Sue's is 30% nut and 70% dried fruit. Jane's trail mix is 60% nuts and 40% chocolate chips. So what's common? Nuts is common. If the combined mixture of Sue and Jane's trails mix contains 50% nuts, so I'll just focus on nuts because that's what we just need to do. 30% nuts. This one is 60% nuts. Right? Pen is a bit horrible, but it's fine. If the combined mixture, so now these two are going to combine. This entire mixture is being poured into a jar, a third jar, a bigger jar, which is S plus J. Okay, and this is 50% nuts. Now, why do you think it's not the average of 30 and 60? It should be 45. The reason is, let's say if you had 100 nuts in the jar S and 100 nuts in jar J, then you would have had 30 nuts in S and 60 nuts in J. And if you mix them together, you would have 90 nuts in S plus J. 90 out of 200 would have been 45%. But what this tells us is that we don't know how many nuts are there in S and how many nuts are there in J. So we'll just let the number of nuts. So in a mixture problem, there are 6 different variables. There are 6 different numbers that you're going to be working with. The 3 amounts, which is S, J, and S plus J. Okay, and they're interrelated. And then there are the percentages, which is 30%, 60%, and 50% in this case. If you have these 6 quantities, you're going to draft an equation out of it and calculate whatever is needed. The question is, what percent of the combined mixture is dried fruit? Alright, so we need to calculate the dried fruit, which is 70% of this, but that's fine. Nothing to worry about. All we need to do is first figure out what is S and J in terms of as a ratio from each other. So the equation here would be that 30%, so I'm going to use the next screen here. 30% of S plus, how much was it? Yeah, 60%. 60% of J. So these are the nuts. 30% of S is the nuts from all the nuts coming from S, the first jar. 60% of J calculates all the nuts that are coming from the second jar, and then added them together, you will get all the nuts, the number of nuts that are there in the final jar, which is 50% of S plus J. Okay, this simplifies to all percentages can get cancelled, multiply by 100 throughout, you'll get 30S plus 50J, 60J is equal to 50S plus 50J. This simplifies to 10J is equal to 20S, J is equal to 2S. Alright, this is very important. So J is equal to 2S. Now we can basically explain the entire problem in one variable, let's say S. So let's take a third one. Let's go back to the first slide. So now we know that this is basically 3S. This is 2S. Now we need to figure out what percent of the combined mixture is dried fruit. So all we have to do is we got to do how much dried fruit are there? There's 0.7 or 70% of S. That's the number of dried fruit divided by what is the total number of everything? What is the combined mixture? 3S. This into 100 will give us the percentage. S and S cancel. You get 70, or you get 70 over 3, which is 23.33%, and your B is your answer. And that's it.